All right, we are recording. Sweet. I'll turn you this way so you can at least see me. And everyone, all right, good morning, happy Monday. So good to see you. Well, it's an old mask that I just haven't worn as much because this one was like wider, you could see more, but it's coming apart and it's destroying the bridge of my nose. So it's also like that used to be white. Gross. Yeah. So what I wanted to do was give you as much help today as I possibly can, while also giving you as much freedom to do whatever you think you need. But let's start first with homework 2.7. I have a feeling that this one was probably a little bit more difficult than anything that we've done yet so far, because you were kind of on your own with this graphing thing. Also, the recording from Friday, of course, recorded the wrong camera, and it didn't work out great. So, what I did on Canvas is I put the links to a few things. The answers to this homework are right there, okay, and they will stay there as a guide for you. The review is up there. I will give you the hard copy of the review once we finish up talking about the solutions, and then the solutions to the review will be right there once I get them done. Okay. This link will take you to the info about the test. We'll take the in-class portion, of course, on Wednesday. The take-home, you'll get it from me on Wednesday, and that'll be due Thursday night. And you're going to see that this review is perfect. This is exactly what you need. Okay, so no surprises on Wednesday or Thursday. The in-class stuff will be the 2.4, 2.5 stuff. The take-home stuff will be basically the homework. You're going to see that I'm going to take this homework. I'm probably going to keep like the first sentence of each of these three and delete like these parts, like, you know, how to do it. That'll just be up to you to know how to do. I'm just going to probably do 3 or 4 folks. Okay. But the answers to this homework are right there. Now, I just want to take a minute and talk through these and give you a chance to ask questions. They got progressively harder, for sure, kind of building to number 4, which had a lot going on. So if that threw you off, we're going to take some time to talk about it. But I wanted to make sure that even the easy ones, I know easy in my mind, but the easier ones, you start to feel confident with this, okay? So I'm not going to talk, but because I want you to look and think for a second, but I will answer questions. Gracie. I don't think you have to, do you need the points you already know? No, you do not. But Grace, what I will tell you is that when we get to calculus next semester, next physical year, yeah, I get it. But next semester, when we create tables like these, where we look at important points along the way and the intervals that are created other than them, we're going to want to have those stopping points there, because we're not just going to be looking at like what the point is, but what's happening at that point. Is the graph increasing at that point? Is the graph decreasing at that point? Is it a maximum? Is it a minimum? Is it concave down? Is it concave up? The values of some calculus arithmetic that we're going to do, all going to be in this one place. So I suggest you do it now so it becomes habit for next semester. But how you design your collection of points, up to you. I'm not going to take off points now if you don't have this, but you're going to see if your table in calculus doesn't have that, then it's very incomplete, because of what we're going to need to do on the calculus side of things. But this is the pre-calc side of things. This is chapter 2. So how you design your table, I think, is up to you. And which points you choose, honestly, are up to you as well. But what you see that I do on each of these problems is once I work through A through G, right, It's already simplified, no factoring to do. Domain just can't be 3 because I didn't divide anything away. There's no holes, so it's got to be an asymptote. And behavior got to be y equals 0 because degree on top is smaller than degree on bottom. There's no value of x for me to put into the numerator to make it 0. My y-intercept ratio of the constants. Once I do all of that stuff, the table, how you fill that out is kind of up to you. But here's how I'm going to design my table for 1, 2, 3, and 4. A through G has some x values listed. I don't care about the y values. I'm just breaking my domain up. And I'm going to circle those because those are the points, 0 and 3, that I am going to use as my stopping points to break up my function, okay? And so when I design my table, it looks like this. 2 x values, 3 sections, sorry, people at home. 2 x values, 3 sections, so I've got 5 columns, okay? And so what I do is I draw a 5-column chart. And then I start like this. Negative infinity, I cover up everything else, to infinity. I start at negative infinity, I know I'm going to infinity. Interval, stop, interval, stop, interval. And I'm just gonna fill in those x values first. I fill in the 0, I fill in the 3, because once I do that, I've got only, right now, if I have, I wish I could like cover this stuff up so everybody could see it. Go like this, right? What I would have is that 3 covered up, right? And I fill in like the 0 and the 3 because like these numbers is where one interval stops and the next one starts. These numbers where one interval stops and the next one starts, having negative infinity on the left, infinity on the right, and then putting in those x values, I think makes it really easy for me to design my intervals because that 0 is going to go there and there, that 3 is going to go there and there. And then I just fill in some points, right? Really close to 0. Okay, -1, -2, -3, -4. Stop at 0. Okay, I wrote down the point here, but you have the point here. You don't have to write it down again. Okay, you could just say like y-intercept. That'd be fine. You know, between 0 and 3, you could just go in the middle and do 1.5. I just thought it was nice to have 1 and 2. I just don't have to deal with decimals as much. That choice is yours. It's a pretty small space, so 1 point's enough. 2 is fine as well. X equals 3 was a vertical asymptote. I don't really have to write that down. It's right there, right? But then bigger than 3, 3, 4, 5, 6, and 7. And then there we go, right? Because your y values were really small. Biggest y value, 1. Smallest y value, -1. When I design my space, I want to make it work for me. So I made my x values just go up by 1 for every box, but I made my y values, it took me 4 boxes to get to 1. Because then it's 0.25, 0.5, 0.75. That's a really good strategy if you've got small numbers. Pick a nice setup. You're going to see that in this homework, I either use this scale or a 1-in-1 scale. That's probably your 2 best choices. And I'll probably design our functions so that one of those 2 options work really well. But vertical asymptote there, horizontal asymptote here, you can see I dashed it a little bit thicker, and I drew that dash line to go a little bit past on the left and the right, and I even wrote that little HA there. But again, if you write it here, you're good. If your info is in like the work above, you're done. And you're going to see I'm going to use 1 page for every problem. I'm going to take my time. I'm going to use my space well, and I just plot the points. And I just, you can see I've got these 5 or 6 points plotted over here, and then, oh, as I get close to the left edge, I'm just going to get close to this arrow. As I get close to this vertical asymptote, well, I just kind of follow the points. Oh, they're going down. I better just keep going down. Again, 4 points over here were nice. If I follow the trend to the right, I know I got to get close to this arrow. As I follow the trend to the left, up I go. So I just went. Okay, dash lines for your asymptotes. Solid, connected, smooth, rounded, nice graph. Okay, x and f of x, 1 and 1, arrows in the ends, straight edges for all my straight lines, and freehand for the graph. Okay, and number 2 is really similar. I just had a little factoring to do on the bottom. Okay, and now I do have an x-intercept because -2 will work. But same scenario with the behavior, right? Degree on top, smaller degree on bottom. So I know I have a horizontal asymptote of y equals 0. No holes because I didn't divide anything away. That should say none. There should be an E at the end there. But domain can't be 0, -4. Those are both asymptotes. X-intercept at -2 from the 0 from the top. Now I have 1, 2, 3 x values, 0, -4, and -2. So 3 x values, that means 4 intervals, 4 sections. So I've got 7 columns down here to fill them in, from -infinity to infinity, -4, -2, and 0 from left to right. So this x value is the end of this one, beginning of that. This x value, end of this one, beginning of that one. And so on and so on. And I got some nice points, and oh, isn't that lovely? Okay. And listen, you're doing this on a graphing calculator. You're getting all these points from your table anyway. Press graph, right? Press graph and look at it. Just know that your scale that you've got should probably match the window that you're choosing when you do this. So for me, like I designed a graph that was like -10 to 10 or so, but like -2 to 2, right? Make sure your window kind of matches that so that like the shape of your graph, you can really match up nicely. But I know that you can press graph, so I'm going to be looking more at this than anything else. Okay, this is really what I'm going to be grading. And of course, this is going to be scrutinized and looked at very closely too. Straight edges and points accurately placed and labels and scales and getting close to the asymptote, but trying not to turn back onto itself, right? It's got to be a function, so we want to try it, make it past the vertical line test as much as we can. So you can see, like, as I'm moving down here towards this asymptote, I don't get there right away. I give myself some time to get closer and closer and closer, right? As I get closer here, I don't, like, scoot right over right away. I kind of slowly meander my way closer. And, yeah, it's like, oh, I'm a little closer here than up here. It's not going to be perfect, and that's okay. Just do the best you can, okay? Questions about anything number 2? I don't want to take too much time talking these through. I really would rather give you the chance to ask questions. But something like number 3 and number 4, I wanted to put a hole in there somewhere so you can see what would happen there. But a little factoring up top, pull the 2 out, and then you've got difference of squares. Quadratic trinomial on the bottom, so just 2 numbers that add to -1, multiply to -6. But ooh, look, an x -3 and an x -3, so those divide away. Right? If I was doing this for real, I would put a line through both of those. I just wanted you to see those without the line, but there's a simplified version of that. And because I divided something away, I know I have a hole. The x value for that hole is the 0 from that factor, right? X -3, okay, +3. To figure out the y value that goes with it, I take the simplified version of that function. I come down here and I just, wherever there was an x, I drop in this number. All right, so x and x became 3 and 3. I got 12/5. Fine, 12/5, 2.4. Either one's fine. It's not perfect. I can't plot it perfectly, but I can do the best I can. So 3 and -2 are the x values I can't use, but one of them's for a hole and the other one's for the asymptote. Okay. Same degree top and bottom, so y equals the ratio of the leading coefficients. 2/1, so y equals 2. X-intercept is the 0 from the numerator. That's still there once I'm done simplifying, so there's -3 from that factor right there. And then y-intercept, ratio of the constants. All right, -18 over -6, that's 3. And you have your notes available to you on Thursday to get this done. So not as much to study and memorize this year, so you're lucky. If this was last year, this would have been a much harder unit, I think. But here's what it's going to look like when I break this thing apart. I mean, look at this. I got 1, 2, 3, 4 x values, -2, 3, -3, and 0. 4 x values, that means 5 sections. So I've got a 9-column table here from -infinity to infinity, and then left to right. How you design it's up to you. But what I really want you to see is how I probably could have even made that hole even larger. Okay, now I went 1 by 1 here because my x values and my y values got a little bit bigger. I probably maybe could have gone like 1 and like maybe 2 boxes was 1 because my y values weren't nearly as big. 1, 1.3, 1.5, 1.6. So I had to get up to 4. Maybe that's why I probably went as big as I did. That was the biggest y value. But that hole, you really want to make it stand out. Clear as day. So I probably could have made it even bigger than that. Maybe like half a box on either side is a good width there. Vertical asymptote there, horizontal asymptote there. a collection of points, and I just go. Delaney.
So I'm just like confused on the whole and when we put it in the table.
Okay.
So when we do that, like, so I get the interval from 2 to 0, and then the 0 comes from
the y-intercept.
Okay, the y-intercept.
Yep.
And then the 0 to the 3.
Right. So then
on the whole, right?
Right. So the 3 was a point that I really wanted to make sure I stopped at. It was an x value that was worth stopping at, because I want to make sure that, like, it's a little bit different. Like, as an asymptote, as I get closer to it, we're going to take off in opposite directions potentially, right? But when you approach a hole, you're going to approach it from both sides. And so I want to have numbers. So if I have a hole at 3, I want to look at numbers like 2 and 4 and get those points nearby. So I have like a nice target that I can kind of aim towards once I get there. Now, what you'll see, like, so in this table, I wrote the point down. That maybe isn't the best idea. You're going to see in the table for number 4, I just wrote the word hole because I've got it written down. Right there it is. I know where that hole is in my work that I did kind of leading up to it. And so I actually like my table in number 4 even better than my table in number 3, because at each of my stopping points, I don't write down where it is, I write down what it is. It's an x-intercept, an asymptote, a y-intercept, a hole, an x-intercept. And so I really actually like, and I wish I had this thought when I got to my table for number 3 or even my table for number 1. At each of those x values, these are things you've already written down. So in your table, maybe we just write down the points within the intervals, but at each of our important x values that we're stopping at, let's write down what's happening, not where it's happening. I really like that setup even better. So I like my table for number 4 a little bit better. Let's back up for number 3 just for a quick second. I'm glad you brought that up. That was a good question. Anything else from number 3? Right, getting close to asymptote. It's a good collection of points. If you want more, graph more. I was thinking big sections, 4 of them is good. Gives me a good trend. And I mean, look at these decimals, right? We can't be perfect, but you're going to get closer to the asymptote. You're going to get closer to the asymptote. So leave yourself a little space and do the best you can. If you don't like it, you have an eraser. Just erase. All right, number 4. This is one we want to talk about for sure. The factoring here was just a little bit trickier up top. That is this cubic, right? And you've got this, 4-term polynomial that we can factor by grouping. Okay. Now, if you are not sure if something is factorable by grouping, what I want you to start recognizing is the structure. Okay. Here's the setup if you want it to be factorable by grouping. Okay. We always look at the first 2 and the last 2. Okay. Now look at 2 things. What is the difference in degrees for just these first 2? Same difference. Good. That's what I want. Now check the ratio of the coefficients. 1 divided by ratio. 1 divided by -1. -1, right? -4 divided by 4. Same ratio. Okay. Same difference in exponents and same ratio of coefficients. If both of those are true, this is factorable by grouping. Okay. Because what I can do is take the GCF from here and see what's left, and take a GCF from here, pulling out the negative if I need to, so that these parentheses are the same. Because if these sets of parentheses are the same, I can factor out what the GCF from each into a factor, and then one of these. Okay, and if you recognize that structure, it makes it a little bit easier. Now, what I'm going to do is I'm going to make these as factorable as I possibly can. And if this is degree 3, I'm probably going to find you 3 rational factors. Okay, which means you could just kind of like look at the top and say, okay, I'm looking for numbers like 1, -1, 2, -2, or 4, -4, right? All the factors of 4 divided by all the factors of 1 to see what works. And you would see that it would factor nice. Okay. Denominator is just a difference of squares, so I factored that. But look, an x minus 1 and an x minus 1. So those divide away. That x squared minus 4, though, is even more factorable. X plus 2, x minus 2, and there's that leftover x plus 1 from the bottom. Okay, that's about as hard as I'm going to make this factor. Okay, I will probably not put a difference or sum of cubes. Okay, but I will probably, in order to create this kind of degree difference, right, degree on top larger than degree on bottom, I'm probably going to need to put a cubic up here to make it worth our while. So you're going to want to be able to factor by grouping to do that. I'll do my best to make that work. Okay. Sweet. So you've got these two x values that don't work, negative 1 and 1 from here, right, the original factor. But we divided away the x minus 1, so that's a whole. To figure out the y value that goes with it, I just take that simplified version, I come down here, and I plug in everywhere there's an x, in goes the 1. 3 times negative 1, okay, negative 3 over 2, so negative 3 halves. Okay, this x value that's still there from that factor, that's got to be a vertical asymptote. But then lastly, in 2.6, in behavior, if your degree on top is larger than degree on bottom, you have a slant asymptote. Which means we have a y equals like an mx plus b kind of setup, something linear, because the difference is 1. I'm going to keep it that way so you can actually graph it. I'm not going to have difference of 2 in degrees because it's going to be quadratic. You're actually going to have to divide. All right, so I had to come over here, and because my denominator is quadratic, I had to do a long division. All right, dividend on the inside, divisor on the outside. Look what I had to put in. I have to put in that plus 0x term because it's missing. Otherwise, this is not going to work out as well. First term from the inside divided by first term from the outside, long division. And y equals whatever this is. Y equals whatever that is. Okay? X-intercepts, zeros from the top. Y-intercepts, ratio of the constants, 4 over negative 1. And look, 1, 2, 3, 4, 5 x values. Negative 2, negative 1, 0, 1, and 2 all had stuff happening. 5 x values, that means 6 intervals. There's 11 columns in this table. That's a lot. I get that. Okay, but now you've got these solutions you can look back at, lean on, and there it is, right? X-intercept, vertical asymptote, y-intercept, whole, x-intercept. Find some points, and boy, does that look nice. Right, and what you should be able to do, you have this in y equals already. If you created the table and went in and asked for all those x values, you should be able to just kind of come over to, go away. What do I want? Where are you? Come here, you. It's a different one. What was it? X cubed minus x squared minus 4x, 4x plus 4. Over x squared minus 1. All right? Graph it. Look at it. Now that's zoom standard. I want to square that out so that I get the same kind of shape. And just like go like this. Ooh. Ah. Ooh. Ah. And hey, you know what? You have the slant asymptote, right? You got x minus 1. Graph that. There it is, right? That's that really nice line that the graph is closer to. Like if you screwed something up and you did like, I don't know, like you did your synthetic division or your long division in this case, you did that and you try to graph it and you're like, no, that can't be right. You go back, right? You know if you made a mistake or not because you have a graph that you can go and just type in and see what happens. And if you don't like what you see, go back. Oh, I forgot the negative. I'm so sorry, I can't believe I did that. Ooh, that looks so much better. Okay, now this is not going to let you see the whole though. Okay, zoom standard doesn't do that. Zoom decimal, zoom number 4. We'll show you that hole. Okay. If you zoom out, it's still there. Okay. It's a lot smaller, but there you go. And you can always mess with your window to be the same size as the space that you've got. Now, my y values were a little bit bigger on the negative side, negative 6.4, even negative, where was it, 7.5. Compared to my biggest y value on the positive side. So you can see that my x-axis is not right down the middle. I just moved it up a little bit, so I had a little bit more space underneath than I needed above. But you can create a window, x values, I don't know, like negative 10 to 10. Y scale by ones, or X scale by ones, yeah. Y looks more like -10 to like 7, it kind of looks like. I don't know, you can always count that off. Going by ones. Again, it's not going to draw the hole because you just messed with it, but at least now you've got a slightly, whatever you want. You can kind of mess with it. But there you go. All right, there's 1 through 4. Let's talk more individually if you have questions about that, but I'd rather just give you the rest of the time to start the review. And if I'm you, I'm doing one of two things. I'm either saying, you know what I really need to be able to do on my own is the 2.5, 2.4, 2.5 stuff. So I'm going to do that while I'm here in class and can ask him questions, or I can ask the people around me. Or you're saying, you know what, this 2.7 stuff is really still throwing me off. Maybe that's what I work on right now because I can ask him questions or I can ask the people around me questions. Okay, that is your choice. Okay, this is an excellent guide for you so that you know what's expected of you come Wednesday, Thursday. Okay. I know we only have 50 minutes while we're in here. Okay. But the 2.4 and 2.5 stuff here on the front page and then kind of leaks onto the second page a little bit with part 2. Obviously, it won't be this long. I can't do this many problems in 50 minutes. Okay. But these types of problems are very good examples for what is expected of you, where the last one is probably harder than what you would see. Okay, the last one, especially in 2.5, part 1 and part 2, those are probably just like a one step above the difficulty that you would see come test on. Okay, but if you can do that, then you can do anything. Okay, so we've got, I don't know, 20, 30 minutes, something like that. So get some practice done, but ask me questions. But if you don't have questions, I'm going to sit here and do the solution. Okay, well, I'm going to sit here because I want you to be able to see what I'm doing on the calculator because I'm in 2.5, kind of working through some polynomial stuff. But I'm here to answer your questions. The solutions are second to your needs, which obviously comes first. So raise a hand or give me a shout if I'm not paying attention to you. Folks at home, you obviously have this linked to Classroom, so you can check that out. And I'm here. You guys are in my ear, so just let me know. Sure. All right, so the time is yours. Use it well. If you want to come look at solutions, I've got 1 through 10, like on a separate piece of paper already. I'm kind of looking at number 12 on another piece of paper. But it's right here, right? This review is right here waiting for you. Answers will be posted on Canvas as soon as they're done. Put in music if you'd like, tune out the world, do your thing, but let's get some work done in this last 20, 25 minutes or so. And do as much as you can of this. I think having this and the solutions that go with it will be very helpful for you.
Mr. Rosengren?
Yeah.
So I won't be in class till like the 17th, I think.
Okay.
So am I able to just do the test at home?
Can I shoot you a message on Canvas and we can have that conversation separately to figure out what would be best?
Yeah.
I think I'm gonna do that with everybody. Owen, Brady, Riley, Doran, all you guys. Probably I'm gonna send you a message during lunch today and just kind of make up a plan for whatever works best. I'm flexible. I understand you know, the severity of the situation. So I want to make sure that we do the right thing. So yeah, let's make a plan. So expect a message in about a half hour or so, maybe less. And we'll chat a little bit here the next couple of days and we'll just figure out what works. So what I don't want to do is release the in-class part of the test before Thursday, because that's when Cohort B is taking it. Okay. I want to give them the same opportunities that I'm giving to Cohort A. I don't want to give Cohort B any extra advantage to the in-class part by sending it to you guys like Wednesday, you know what I mean? So that's what I'm thinking. So what I would probably do is I'll send you guys everything. I can send you the take home stuff on Wednesday, but I'd probably send you the at home stuff on Thursday, kind of thing.
Yeah.
Cool.
That works.
But I'll send you a message and let you know. Thanks, Sam.
Thank you.
Yeah, no problem. Yay, question. What's up, Grace?
Remember to define this, but
Okay.
in order to start like long division of synthetic division, factor do I use, or do I use all of them?
We're going to use all of them.
Oh.
So really what we want to do is once we, like number 10, all right, the 3 complex zeros. Ooh, I found all 3. Good. They're all rational. Yay. I just want to prove that with that kind of stacked synthetic division. It doesn't matter what order you go in. I found them in this order, so that's the order I'm going to write them in, where I put the actual answer on the left, the coefficients for the function, right? I leave a space for the work, and then I bring down the 1, zigzag, multiply, add straight down, zigzag, multiply, add straight down, zigzag, multiply, add straight down. I got 0, yay, so I'm good. And now these are the coefficients of like my remaining factor. Now I do it with 2. Bring down the 1, zigzag, multiply, add straight down, zigzag, multiply, add straight down. Yay, there's another 0. So I just want to kind of use synthetic division to prove that what I did was right. That I typed it in right, I found the right zeros so that it worked. And I do it again.
If we find all 3 degrees, all 3 actual zeros,
yeah,
then we should get 0.
We should get 0 for all of them. Yeah. And so this is just kind of a visual proof of what the calculator told us. And we want to have this as kind of a backup because I can't see you in the calculator. I can't see that you're typing this in. This is going to be my proof that, yeah, these are in fact actual rational zeros. So I want this as proof, even though I know what it's going to look like. That's going to be it, because x plus 1 gives me to there, x minus 2 gives me to there, x plus 4 gives me to there for sure. I just want to use synthetic division, right? Cool. 3 complex zeros. Yep. Found all 3. Great. How does that factor from there? Well, this, right, it kind of depends. Right? Do I just use this 6 as my leading coefficient and I leave them as fractions? Or do I multiply this one by 2 and this one by 3, multiplying the whole thing by, and I'm kind of like distributing the 6 the way that I want to write them like that. So either one's fine. But I want to see that synthetic division help out, because now with number 12, degree 4, only 2 rational zeros, and I checked the graph and they cut through my lines. So I know the multiplicities are only 1, so I can only do it once. But I want to be able to do that because now I've got that leftover factor, because part E says find the remaining zero. And if I don't do this, I don't know what that leftover factor is for me to set equal to 0 and solve.
Okay.
Does that make sense?
Yeah, so after you use those 2 actual zeros that you have to sound, then you just set the remainder.
Exactly, right? Because this right here, degree 4, degree 3, okay, degree 2. So this is my quadratic, my linear, and my constant coefficient. So 1x squared plus 0x plus 4. So x squared plus 4 equals 0, right? Because part E, find any remaining zeros algebraically if we have to, right? And you're going to say like, nope, don't have to. Nope, don't have to for 10 and 11 because we found all of them, right? But for number 12, yeah, I've got this leftover factor. I want to figure out what those complex or irrational zeros are going to be.
Okay. I remember talking also for the multiplicity if it was anything else, like if it wasn't a straight line. Even if it was just 2.
Right. Yeah, check this out. Read. Where's my... Like you're going to see number 13, this degree 5. I think there's only 2 zeros, but one of them has a multiplicity of 2. So you're going to see one of them like cut through like a line, but the other one like bounces off. And you're going to want to do synthetic division with whatever that 0 is twice. Because you get to this cubic, like, I don't know what to do with that. I have so much more work in front of me, but quadratics are easy. I just set them equal to 0 and I can solve for it, or I can quadratic formula, or I can do whatever I need to find that last 0.
Okay. Yes.
Cool.
Makes sense.
Yeah.
Thank you.
You're welcome.
I have a graphing question for the calculator.
Okay.
So this one is a different version than the one that we've been using. It's the 8 zip.
Yeah.
So it keeps showing the vertical asymptote,
Cool.
which is kind of throwing me off.
Okay.
But also, like, I don't know how to turn it off.
So, yeah, it is definitely something that we don't want to see as part of the graph. If it was dashed, maybe it wouldn't bother us so much, but the fact that it's there solid, not so great. Let's play. I don't know where. I'm going to go looking. Usually what I would be looking at would be something like format. Yeah, yours is definitely a little different. Catalog.
Said he got it in college.
Yeah, it can do more than the 84s can for sure. But like, you know, moving all the stuff around really kind of threw everybody off. So they went back to the 84, just made it better. That's when the 84 Plus came out, and then the 84 Plus Color Edition came out. Then they went to like the 89 and the Titaniums, and then the Inspires, which are crazy. Anybody? Click somebody. Oh no. Somebody in second, Alora Rankin, has an Inspire, and they're amazing. They are like $180 calculators. Yeah, they're really nice, but I was trying to go to catalog to see if I could find format. In graph, window zoom trace. I guess that's just graph. All your zoom options down there. Yeah, let's do that. Now I gotta wait for it to. I think we're just gonna have to deal with it, because I could play forever and maybe never find it. Because what I'm trying to find, I don't even know if it would be in there. I'm trying to find that. Because in format, you can mess with how stuff looks. So, I don't know, have you guys ever done polar graphing? Oh, it's not going to do anything. I would need like, no, it still does like that. Anyway, it's like, so instead of boxes that are squares, imagine looking down onto the North Pole. You can see the increasing lines of latitude coming out as like concentric circles, but imagine that just going on forever. Imagine the Earth was infinitely large. Yeah, it's the coolest thing. Well, I'm hoping we get to it at some point. You can do it on decimal, it's really cool. And then this has nothing to do with what we're talking about, but polar. Super cool. Yeah. And some of the graphs. So polar is like chapter 9, I think. I don't need chapter 2 anymore. I think it's chapter 9. Yeah. Oh my God. I just have to show it to you because it's so cool. I hope we get to it. I don't know how. We won't graph these by hand. So when you're graphing in polar, it's not x comma y. It's r for the radius and then theta for the angle. So every point isn't x, y, it's r theta. So like opening up this angle. But the graphs that you can create in polar are so freaking cool, man. So pretty. They're incredible. Right?
You ever wanted to graph a flower?
Mm-hmm. right? I knew there had to be some cosine and sine stuff. There's a lot of trig that gets you there. But it's just so cool. Anyway, so I don't know what to do. I wonder. So let's see. TI 86 graphing vertical asymptotes off. See, the world knows that the 86 is really just but here's the whole guidebook. So if you did you?
I had to figure out how to graph stuff on it because it didn't have.
Right. Yeah.
He's like, I got nothing.
Yeah. So this will be pretty helpful, but I don't know. And it can do a lot of stuff that the 84 definitely can't, which is really nice. But it's not great if we don't know how to find it, right? So yeah, I guess for now we'll just ignore it and know that it exists as a dotted line instead of an actual part of the function. Yeah. Sorry, I wish I had a better answer for you. Where'd my pencil go? I thought I felt it fall out of my ear. There it is. So last couple minutes, get yourself to a decent stopping point. Thirteen's a fun one. I don't know if I'd make it this fun on the test, but it is nice. And you do have the whole day. This one isn't timed, so I don't know. Maybe I'll make it fun. Well, at least the rational options aren't that bad because 13's prime, right? So you don't have a long list like you did for 12 because the factors of 60 are crazy. 1, 2, 3, 4, 5, 6 all go evenly into 60. And then all of their factors go with it. 10, 12, 15, 20, and 30, and 60, right? So that was a long list. But this one, when I look for, right, there are 5 complex zeros. I wonder if, so real quick so you can see it since you guys are here. Let's go back to Desmos. And the first thing I'm going to do with every single one of these is just graph it. And typing it into here is just going to be a little faster. To the 5th, oh, to the 5th, to the 4th, to the 3rd, to the 2nd. There's 1 at -1/2. And there's 1 at 1, but you see how it hits it like a parabola? The multiplicity is 2 at that spot. So I have x -1 twice, which means when I do synthetic division, I'm going to do it twice. And that's going to help because if I have degree 5, I'm hoping for 5 zeros, and I have 3 rational ones. -1/2, 1, and 1 again. Hi.
Can I check 1 through 9?
Yeah.
How badly did I do? I didn't check my notes, so I just do it.
Well, that's good. I like that. That's a good test.
Though. Yes. 151 to 17. Is that
So,
okay, or do we
no, pull the I out because it's A plus BI. So you don't want to have the I as part of the fraction. We want to have that out separately.
Okay, and then I just
Probably need to do that on that one, which is good though. Good. Same there. Good. Those are good. You got 2.4. Good. Thanks, everybody. I will see you Wednesday. Check Canvas probably by the end of today. Wednesday for solutions. Hopefully I can do them while my Algebra 2 is taking the test. Thanks everybody at home. Any questions? How do you guys do? All good?
Hi, thank you.
Welcome, thank you. So check your Canvas inbox in the next 20 minutes or so, probably even shorter than that. I will reach out to kind of make a plan for what you guys want to do in terms of taking the test, either like coming in outside of school time or me just sending it to you and you doing it remotely. We'll have that over.
Would coming in during our normal class period be fine? Because I've done that for other classes.
That's fine by me, because you're self-quarantining on it's not something that is like forced upon you, because you know we've had some exposure going on here, which is why there are a few extra people that are at home, like Emily and Doran. They were in a different class where somebody is presumptive positive. So, but you're just keeping away as best you can. So I would love it if you could just come in. Yeah, that would be good. You can just come in, take the in-class part, and then head home.
All right, yeah. That should work. Right, thanks.
All right, see ya.
See ya.
Thank you.
Bye, Riley. You're welcome.
Bye.